Okay, free fall is like the motion of an object under the force of gravity, and it basically means like the greater mass, it means it falls down faster, but the less the mass, it falls down slower.
All right, okay, fine. Then, moreover, if we have more cases about free fall, like what are you getting from here, from this picture?
Um, like it consists of like air resistance, and there is an example of a parachute, and basically when a parachute opens, then the surface area gets bigger, and it makes up air particles hit it more, and it makes it like slow down.
Right. So that means the greater surface area will make the parachute slow down. Okay. This is what you said, right?
Yeah.
Okay. All right. So moreover, we have another thing here. Yes, from these pointers, what would you like to share?
And then we spoke of air resistance. So there was an example of um, a feather and a bowling ball drop down at the same time. And if there's no air resistance, then it would reach down at the same time. And the only force acting like against it is its weight.
Okay.
And when one object accelerates towards the ground, with the constant acceleration, um, it has like a constant value as well of gravity, so 9.8.
All right. So when there is no air resistance, so the case is going to be like they are going to fall with the same same speed. Yeah, that means there is a vacuum. Okay, so if the two objects are allowed to drop, they are released from the same point, so they are going to reach the ground at the same time. If this event is performed in the vacuum, so this is going to happen, right? So this is called the free fall motion. Yeah.
Yeah.
So you have, as you have just mentioned, that when there is no air resistance acts on the body, so there is only the weight that is acting on the body that makes it fall down. So it is the force of attraction, right, between the object that is coming down and between the planet or the surface of the earth, or if it could be any other object that is pulling the object towards itself, right? So this is the force of attraction between two objects. The one is coming down and the one is pulling that falling object, right? So you also mentioned about the acceleration, that the object accelerates towards the ground with the constant acceleration, which is a constant value, that is 10 meter per second square. That means in every second the body is going to accelerate. Yeah, in every second the body is going to speed up by the amount of 10 meter per second. Yeah.
Yeah.
All right. So what about this free fall? Can you please brief me about this? What is discussed here? Starting from point A, you can take a reference. Point A, where it has covered 5 meter, and then after 1 second again, it covers 15 meter, and in the next second it covers 25 meters. So can you please take me with that?
Okay, so
Yeah.
from A to the last point, every second, the ball moves, like the velocity gets faster by um 10 meters each, and we
10
drew a
meter
graph
per
on it.
second, per 10 meter per second in each
10
second.
meter per second each, and then the distance also goes 10 meters each time, and then we made a graph on it and like made the line of best fits for velocity and distance.
Right. So we plotted two graphs, right? So from this the illustration of the object that is coming down, and it is speeding up in every second. So we made two graphs here one is the velocity time, and one is the distance time. So as you can see here, the velocity time is the straight diagonal line, right? That indicates there is a constant acceleration, and the body is speeding up with the same amount in every second. And moreover, if we talk about the distance time, so it goes on with this, it keeps rising, and the rate of change of the speed increases, right? So are you able to describe in this way that rate of the change of speed increases? Yeah,
Yeah.
right. So that is the gradient. Okay. So the distance time, the gradient of distance time tells us the speed, right? The gradient of
Yeah.
distance time tells us the speed. So at every point, the rate of change of the speed increases. So that means the gradient increases, right? So this is how the body is going to speed up. So we plotted these two graphs by considering this object that is coming down. So today we are going to talk about the terminal velocity, right? So let me dive you to the terminal velocity. Uh, what do you think if the object is started coming down from one point? So how it behaves in the starting, and then it comes to at a certain speed, and then it goes on to speed up, or it continues to move with the same speed. So what do you know about it? Any idea when the object is allowed to to fall? Any idea what happens at different moment?
When an object falls, like its falling speed can get faster.
Okay, so it's a speed going to be more and more, right? Every second. Okay.
Yeah.
So can you connect that air resistance is going to increase as well? Don't you think that if the body speeds up, so the air resistance would also increases? Yeah.
Yeah.
Can you please recall where did I discuss it here? Did I discuss here or okay? So have I not discussed? No?
No.
Oh, okay. All right. So I need to, first of all, I need to discuss that air resistance. What happens to the air resistance, right? So let me draw this concept here. So air resistance or drag, air resistance or drag. So can you please brief me what air resistance is? Any idea about air resistance? Is it
It's when the air particles hits an object and it causes it to get slower.
so it's a air resistance, the opposite force, right? It is
Yeah.
the resistive opposite force. Okay. So this refers the resistive force that that acts on an object when when it moves, when it moves, or when it is moving through through air or liquid. So if I write through fluid, so will it be okay or not? Through fluids. Yeah. So the fluid
Yeah.
means the air, or that means the gases or liquid, right? Okay. Um, so air resistance, depends on the three factors, right? Number one is um air resistance, the surface area, right?
Yeah.
Surface area of an object. Surface area of an object will have will affect the air resistance. That means greater surface area, greater the surface area, more the air resistance will be. More the air resistance will be. Right? Second, what do you think? What could be the factor that can affect the air resistance?
The weight of the object.
Okay, fine. So what we can say that if speed, okay, let me include speed first, and then I'll talk about that. The speed of an object, right? Speed of an object. So if the object is if the body speeds up the air resistance increases, right? So I'm going to talk about that as well. Um, Speeds up, the air resistance increases up to certain level, right? Up to certain level. As more number of air particles, as more air number of air particles strike on the moving object. So what do you think if the body speeds up, so air resistance is going to increase. So will the body not able to increase the speed? Will it get slow down, or
Yeah.
can it increase the speed?
If more number of particles are hitting it, then it's gonna slow down.
Okay, fine. So that means if have applied, see this object is moving, right? Okay, so let me draw the diagram here. Um, let's say the object is coming from left to right, and here are the air particles, right? So if the object speed increases, right? If the object speed increases, so more number of particles are going to strike faster, right? More number of particles are going to strike faster, so the air resistance increases. But on the other side, when we say that body speeds up, so that there's going to be the unbalanced force that keeps acting on the on the moving object, right?
Yeah.
So unbalanced force, unbalanced force is acting is acting is acting to speed up the body, right? To speed up the body, right? This is how the body can speed up. For example, the air resistance uh can apply 5 Newton force, okay, and the body is speeding up from 7 Newton to from 7 Newton to 15 Newton, right? And the air resistance from 5 Newton to 5 Newton to, let's say, 8 Newton, right? Okay. So what do you think from 7 to 15, yeah, and from 5 to 8? So if we find out the change, right? So if we take the initial data was the initial data could be 7 Newton and the 5 Newton, right? So what is the difference? From left hand side, it is 5 Newton, and from the right hand side, it was 7 Newton, right? So what is the difference? You are going to 2 Newton, you are going to get 2 Newton, right? Now, the
Yeah.
second thing is that when it reaches to the 15 Newton, so the air resistance also reaches to 8 Newton. So there is an increase of the air resistance, right? So now if I take the difference of, 15 Newton and 8 Newton, right? So what am I going to get? Yeah,
Um,
7 Newton. Yeah.
yeah.
So is there an unbalanced force or not?
Yeah.
Right? So do we have a difference of the change of the force from the initial data to the final data or the next data? Yeah, so there's a difference,
Yeah.
difference of the unbalanced force as well. So this is how the body, keeps increasing its speed, right? So there's a change of the 5 Newton from from 2 to 7 in the resultant force, right? So that is the unbalanced resultant force is there. That is 5 Newton. That is how the body is going to speed up. Although when the body speeds up, the air resistance also is also going to increase, right? But it does not mean that body is going to slow down, because the air resistance, it is not able to stop it. Okay, right? Otherwise, if it can stop the moving object, so the difference of this and this is going to be what? Is going to be zero, right? Yeah.
Yeah.
Okay. So when the resultant force becomes zero, the object is going to either become at rest, or it will continue with what? If the forces are balanced. If the
The
forces
balanced forces.
if the forces are balanced, so either the object will become at rest, or
Constant speed.
yeah, it will continue with the constant speed, right? So the two factors I have discussed right now here, surface area. One is the surface area, and another is the speed of the object, right? Okay, so the third
Yeah.
is going to be the density of the fluid. Density of the fluid, right? Density of the fluid
Yeah.
in which the moving object in which the object moves, right? In which the object moves. In which the object moves. Okay, so that's going to be, the third factor. Okay. For example, if I give you the two cases, you have here you have two containers. Okay, and both containers have the equal volume of, one has the water, okay, and one has let's say honey, right? One has honey inside it. So and the same object of the same mass is going to allow to move in the fluid. So which one will have the greater resistance? Yes. Which one will have
Um,
greater resistance?
the honey.
Honey, right? Because the density of the honey is going to be greater than the water. Okay. right? So I hope this point is clear to you. So let's move to the terminal velocity now. So I asked you one question. So if you if you release the object from one position and it is going to fall, so initially what happens? Yes. Initially, what happens to the object?
Oh, it will like, it's gonna like be slow.
Okay, so don't you think that it's going to speed up initially?
Oh, yeah, it's gonna speed up then go slow.
Okay, right, good, that's great. So initially, the object, when the object starts falling, initial drag force is going to be zero, right? Initial drag force is going to be zero, right? So only the weight, only the weight is acting, right? So the acceleration is going to be 10 meter per second square, right? And it is due to the gravity. So what happens when it continues? Uh, when it continues to, when it continues its motion. So over here, I can write the speeds up, right? Yeah, speeds up. Okay. So when it continues its motion, the drag force increases, right? So that means drag, that is the opposite force, drag force increases, right? As speed, increases, right? So what happens is if we take the sum of the forces or the resultant force, so the weight is the downward force. Yeah, weight is what? The downward force, and the drag is the the opposite force. Okay. So what happens is the body is going to, the change of the speed decreases, right? The change of speed, decreasing. Why the change of the speed starts decreasing?
Um,
Okay, let me draw one
because
example. Okay, let me make it more simple. Over here, the object had only this force. Let me write it here. The object has only this force, right? Now in the second point, where I have mentioned the drag force increases as the object increases, because in the initial point the body is going to increase the speed, right? So what happens is the the weight is there, the weight is not going to be changed, right? So the what is going to rise? What is going to rise on this? Drag, right?
yeah,
Okay. And over here, do you feel that there's a drag initially?
yeah.
No, my God, no. How? I have already mentioned it here. Initially, the drag force is going to be zero. So there's no drag in the starting position.
Oh,
Okay. Right. So what happens is, can you see the size of the arrows? Drag, I have drawn the smaller arrow of the drag, and still the size of the weight is greater than the drag, right? So it keeps going on, right? So moreover, when the uh, when this happens, mm, in the third case, when the body is going to continue with its motion, so what happens is the size of the weight and the size of the drag drag force, what do you think, are they going to be equal in size? Yeah.
Yeah.
So that means the drag force becomes equal to weight in this case, right? Okay, so the resultant force, that is the sum of all force, becomes zero. Or you can also write in this form, resultant force becomes zero. Clear? Is this clear? Fine. And
Yeah.
what is the value of the acceleration? What should be the value of acceleration? Acceleration is something that refers to the change of the speed. Okay. So what do you think when the resultant force becomes zero? So what should be the acceleration? Kindly.
0.
Yeah, that's going to be zero. And if we can recall Newton's second law of motion, so the acceleration is directly proportional to the unbalanced force, right? It's directly proportional to the resultant force. If the resultant force is zero, so the acceleration is going to be zero as well. Okay. Yeah, that's great. So because there is no change of the speed that we are observing here in the third case, so the speed, sorry, the acceleration becomes zero. So there is no change of the speed, right? Yeah,
Yeah.
change of the speed is zero. Change of speed zero. So when the change of speed is zero, so is the body at rest? Do you think the body is at rest or it is moving?
When?
In the third case, over here.
Oh, it's at rest.
A rest. Oh my God. So it's going to be stuck in the air. It's going to
Oh, not in the air.
it's going to hang in the air without support. So there will be the Bluetooth technology. The Wi-Fi connections will be there.
I know it's going to fall down.
Yeah, it's going to fall down, but with the increasing speed, decreasing speed, or the constant speed.
I think constant.
Yeah, constant speed. This is what I taught you. When the forces become balanced, that means the resultant force becomes zero, and the object is going to move with the constant speed, right? So over here, the body reaches to constant speed. That means the body is not changing its speed, right? Constant speed. Okay. So here, this constant speed finally, that is known as terminal velocity. Right? So terminal velocity is what? It is the maximum speed an object reaches when moving through a fluid due to the balance forces, that is no resultant force. Okay, so quickly you can write down the definition, and remember terminal velocity explanation usually it comes in the exam as well. Okay, so write down the definition. The maximum So is this clear now? The maximum speed an object reaches when moving through a fluid due to the balance forces, no resultant force.
Yeah.
All right. So can we have the example of the parachute? Yeah. You know, when the parachute opens, the large surface area increases, the drag force also becomes greater, right? So in the next step, what will happen? It will start moving with a constant speed, right?
Yeah.
So let's have a discussion around um this thing in the or so this is going to be initially the weight is there, and when the parachute opens, so what happens is the drag force is there, okay, and over here you have to name it, label it a weight, okay. So what happens is um parachute opens. So what happens? The large surface area increases. Yeah, the surface area increases. So the drag force, the sorry, the drag force, the drag force to act upward. Okay. So what do you think? What will be the resultant force? How can we find the resultant force? We can find the resultant force by subtracting the drag force, okay? Or we can have a difference of the weight and the drag force, right?
Yeah.
Okay. So the resultant force starts acting upward, right? It starts acting upward. When the resultant force starts acting upward, are you getting what resultant force starts acting upward mean? No?
Yeah.
Okay, so that means a greater force is acting upward, right? So resultant force starts acting upward. So as a result of which the speed decreases, right? Yeah, the speed
Yeah.
decreases. So after that, what happens is, when the both, if the both forces become equal, oops, why it's not being copied? So what happens when when the drag and the weight both becomes equal? So what is going to happen? Does in the same thing that you are going to discuss here, the drag force um decreases as the speed decreases, right? Because we have already developed this understanding. When the object speeds up, So the resistance, air resistance or drag force also increases. If the object decreases the speed, so the drag force will also be, or the air resistance will also be decreased, right? So resultant force, starts acting upward to decrease. And what happens? The deceleration is observed by the object, right? When what happens when both become equal, so the resultant force becomes zero, then acceleration will also become zero, and the speed becomes constant. And this is how the object reaches to the terminal velocity, right? So I hope the two cases are clear to you. They are the similar one, they are the same. Okay, so you have to understand and develop this understanding how to explain in the exam. Clear?
Yeah.
I'll share some practice questions with you, okay?
Okay.
All right, okay. Assalamu alaikum.